let me explain a program to transfer a block of 5 elements, transferring between two block of internal RAM locations. So I have chosen here 55 elements to be transferred. Source block I have chosen as 50 and destination block to have 60 as the first address. So R0 points to 50 and R1 points to 60 and R2 will be counting the number of element transferred, which are 5 in this example. I am going to repeat some instructions such as these two. First of all, R0 which is pointing to 50, data from that location is transferred to A. So data that is there in 50 transferred to A. From A, it is transferred to the location pointed by R1. R1 is pointing to 60. So data from 50 is transferred to 60. Now both R0 and R1 are incremented by 1 here. Both R0 and R1 are incremented by 1 because after 50 and 60 we are going to 51 as the source, 61 as the destination. Now R2 which has got 5 as its value decrements by 1. If it is not 0, the execution control goes back to this location. So once again, now R0 at present pointing to 51 after incrementation. So from the location 51, data is transferred to A. From A, data is transferred to 61, which is pointed by R1. So 51 and 61 are involved in data transfer. Now R0 and R1 both increments by 1. So that R0 points to 52 and R1 points to 62. R2 once again decrements by 1. So it becomes 3. So 3 is not equal to 0. So the control goes back to back. So these 4 instructions keep on repeating to transfer from source location to A to destination, and both R0 and R1 are incremented by 1 step after transfer. So like that it goes on till R2 decrements to 0. R2 has got 5 as its value. So 5 times these 4 instructions are executed to transfer from source block to destination and point us to increment by 1 step. So here the last instruction is labeled as year short jump to the same location. So the execution control remains floated in this position so that the next command program will be accepting. So end is the assembler directive which will control the text of the program. So this is how the program is all about. Let me save that program and I'm going to first of all add this program to the project, which is called as block. So block extended with S is added to the project. Then I am going to build to assemble the instructions onto machine code. After building, I am going to debug. So limit 2 kilobytes are okay with me. So I just make it okay. Now 50 is the source block, 60 is the destination block. I am going to put into source some values 11, 22, 33, 44, 55 are the 5 values put to source location starting from 50 to 54, 5 locations. Now I have to observe in these locations where source data to have arrived after executing the program. Now let me run this program and stop it. Now I find 11, 22, 33, 44 and 55 have arrived from location starting from 50. So this is how this program works in order to transfer a block of data from one internal RAM to another internal RAM. Now I will reverse the debug. I'm going to open another program. This time I'm going to exchange. I'm going to exchange between internal RAM of 50 and external RAM of 0010. Once again 5 elements. So previous program I'm going to remove from the project. So this program I'm going to save it. So in the first location R0 is made to point at 50. DPTR, which is a pointer for external RAM, is made to point at 010. R5 will have 5 elements because I am exchanging 5 elements. So how would this program work? This program work to exchange 5 elements by repeating a group of instructions 5 elements 5 number of times. So it is labeled as bag, which consists of these 5 instructions which will involve in exchange of data. How would I do that? In the first instruction, I am going to transfer from the external RAM to the register A by using the mnemonic MOVX. So 0010 data comes to A. Now I am exchanging A content with the internal RAM. So A which I had got it from external RAM, exchanging it with internal RAM. So A which got from 50 location is going to transfer it to the external RAM pointed by DPTR. So these three instructions are repeated 5 times to transfer exchange between external RAM and internal RAM. So every time I exchange one data, I am going to increment both the pointers, both the external RAM and the internal RAM pointers are incremented to update. So R5 will ensure that repetition happens 5 number of times. So decrement jump on no 0 of R5 to back. So control keeps going to these instructions to exchange between external RAM and internal RAM and incrementing of the pointers. So here again, here short jump here to float the end of the program. End is the assembler directive to conclude the text of the program. Now I am going to add this program to the source group of the project. This has been called as exchange. Exchange extended with yes is added. Close. I am going to build to convert it into machine code. I enter debug format. Okay. Now internal RAM is 0050. External RAM I am using. So I have to select it by x colon 0x0010. So now I am going to put one segment with one set of values. Here no source and destination. Here both are exchanging. So I have to put elements in both the locations. Here I am going to put A, B, B, C, C, D, D, and E. So now both the blocks, internal RAM have got 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. External RAM has got AA, BB, CC, DD, EE. After running of the program, this AA, BB have to go to 50 and 1122 have to come to 010 onwards. So I'll run the program and stop to find the below locations have got 112233 and upper location internal RAM have got AABBCC which have got exchange. So you can repeat the same program again. You reset and run the same program. This time 1122 onwards go to 50, AA comes to 010 onwards. So every time you can reset and run to find the exchange happening between internal RAM and external RAM. So this is how this program works. Thank you so much.